All right, today's Math in the News has to do with Steepest Streets. So those of you that live in California have been to California, if you're viewing from other states or countries. And there are steep streets all around, but it seems as though San Francisco is well known for them, but not as well known as some other places around the world. So let's take a look right now. So there's a new Guinness World Record, just came out. It's a street in New Zealand. Now, when students see 34.8%, that's not degrees. It's 34.8%, which is a different measurement than when you're thinking about degrees, because 34.8% is rather steep. And you can see a steep road right here. And a lot of times people don't like driving on them, especially if they have a car that's manual shift and they're like, all right, I gotta keep this thing in gear while I'm waiting on the street. But anyway, we're gonna talk about this world record quickly. So we can see that it has now been surpassed. So Fjord Penlec in Wales was at 37.5%. And you can see some of the other streets, and there are a couple in Los Angeles and San Francisco, but there are steeper streets in other states and in other parts of the world. So you can see what the different measurements are. They're all relatively close as far as percents, but the degree of steepness on this is more than you would think as far as a percentage goes. So, moving on. So the new one, right, it would seem that Fjord Penlec would be steeper, but in 2020, Guinness updated the measurement criteria to base it on the central axis of the road. So that is why Fjord Penlec came in at only 28.6%, because they changed the axis on the road as far as that central one. Now we're going to go into what this means for you. You're not going to be dealing with degrees or percents a lot as far as measuring things, but a lot of students will see things like this and they'll go, that looks like the steepness of a road. You're going to be able to measure degrees. So with a protractor, you're going to be able to measure degrees, and there are usually three different types, common types, that most students will deal with in school. You have a right angle, which is 90 degrees. An acute would be less than 90 degrees, and an obtuse would be more than 90 degrees. And a straight angle would be the 180. But what we're going to do is we're going to take and we're going to try to measure these ones right now. So it's important that when you have a protractor, and especially if you have a ruler on the bottom of it, you want to make sure that the bottom line is lined up with the bottom of the protractor at 0, okay? So now what we're going to do is we're going to measure, we know that this is opening up further than a 90-degree angle. Here's 90 degrees straight up and down. It's going past that, so we can see that this angle is at about 145 degrees. So that would make that an obtuse angle at 145. We can already tell that these ones are going to be less than 90 because they don't open past that 90-degree mark. So these are smaller, so these are going to be acute, so we already know they're going to be less than 90 degrees, but let's see how close to 90 degrees they are. So we'll go to the first one right here. We will get this lined up. And we will move it so that we have my 0 is close to this line. And I know the technology will help me. And we're right at about 70 degrees. So you can see it's relatively close to 90, right? But it's only 70 degrees, which is significantly less than the obtuse one we had before. So we'll move it over. This one's going to be even less. And we can see this one's going to be a little less than 35, so it's actually about 33, 34 degrees. So that is a little bit on how you can start seeing degrees when you start using protractors. And do remember that there are three main types of angles that you'll be dealing with protractors: right angles, acute, and obtuse. And we'll be back with more right after this.